Thanks, Kyle. We're back, as he said, in the Neutral Buoyancy Laboratory, and this time we've got Tim Goddard here with us. He's the flight lead for the Neutral Buoyancy Laboratory, or NBL as we call it here in NASA speak. And he's going to tell us a little bit. First of all, how about tell us what the NBL is? Giant swimming pool, obviously.
Giant swimming pool. Okay, the NBL is the Neutral Buoyancy Laboratory. What we do here is to train astronauts to do spacewalks. So anytime they have a planned or contingency EVA, extravehicular activity, they'll come here first. They'll do 1G training, tabletop training to learn the tools, the pieces, and the parts. And then we'll finally get them in the water. And first in scuba, they'll learn the work sites, learn the different facets of the specific tasks they're going to do, and then they'll finally get in the suits themselves. The suits themselves are downgraded suits. They used to fly, most of them, and now they're rated for the NBL.
And so the astronauts who are on the space station right now, they've been in the NBL and trained for spacewalks and things like that?
That's correct.
And so now, though, we're also using it to get ready for the Orion program, which is, again, our new spaceship that we're building to take humans into space, getting ready for its flight test scheduled for September of 2014, and doing rescue and recovery operations today. So what all is involved in that?
So what the NBL's part in rescue and recovery is the port capsule you have here, post-orbit type stuff. Once they splash down, that's where we come into play. Once they splash down, Navy divers are going to have the primary means of recovery. We're going to use a surface ship, an amphibious ship, to motor up to it. We're going to deploy small boats, like you can see right here, the rubber rating, CRRC, Combat Rubber Rating Craft, or Zodiac as it's commonly called. You're going to have a couple Navy diver teams in these things, and you're going to have a larger boat, which we call RIBS, Rigid Inflatable Hull.
Rigid
boats.
Inflatable Hull?
Rigid hull inflatable boats.
Okay.
So you're having these different small boats in the water. They're going to motor up to the capsule and the parachutes and the forward bay cover and the different items that have fallen, hook buoy lines onto them, stand off once the hydrazine and the ammonia and all the stuff is vented out and it's safe to approach. They'll go up, attach towing lines on it, towing depressors, sea anchors, and handling lines.
Okay. And so for this flight test, it's not going to have any astronauts in it, but in the future, certainly it will, and they'll be coming back from long stays in space. So there are probably a lot of things to take into account. You have to be, of course, careful and safe when you've got people in it.
Right. So essentially, that's why we're here today. This is we use the analogy of crawl, walk, run. This is the crawl phase of training evolution. So we're bringing active duty Navy divers out from the East Coast, which is where we're going to train first. And then we'll go out to San Diego and then finally off the coast of Baja, California.
Wow.
So this is the very slow procedural development phase of it. We're going to do everything safely. Dirt dive it, dive it topside before you really get in the water and do it.
How helpful do you think it is to have this facility to be able to do these kind of practice runs in?
Once again, we're a unique facility in the world. You can't really provide what we can provide here. The Navy has several facilities, but they can't provide the water, the machine shop next door, we can tap into NASA technical expertise right down the street, as well as our common video system, the HD cameras and things like that.
Yeah, well, and speaking of the Navy, tell us a little bit about that relationship. How does that work?
So we've been doing this for a couple years now, and up until this point, active duty Navy hasn't participated too much. So we've had Navy reservists, local Navy reservists, divers, SEALs, and EOD folks that we'll bring into the NBL, and they've been evaluating the hardware. This is the first time we've actually got active duty to bring in an active duty master diver as well as diving warrant officer, and they're the hands-on. So these aren't the two folks that are going to actually go recover the astronauts or the capsule, but these are the ones who are in charge of the training plan and in charge of the sailors who are actually going to do it.
Okay, so we're getting closer and closer to the point of actually training people to go do it.
We're getting there. Hopefully sometime coming up in this summer, we'll have a troop of mudsuit divers, mobile diving salvage unit divers coming out here and doing a training class.
Great, maybe we'll come back for that.
Hope so.
So we've got the port mock-up behind us, right? That's what we use here for the testing in the NBL.
That's great.
And what's going to be going on here today?
So yesterday we had the forward bay cover, which you can't see, unfortunately. It's behind the port. That's just a section of it that will come off during during descent. We did recovery operations on that and make sure that we can motor up to it, hook up to it, flip it over, put lift bags on it, and put a towing line on it, and actually tow it with these boats. Today, what we're doing is we're doing attachment systems on the capsule itself. So there's 3 attach points, 1 primary and 2 secondary. The primary is a towing point. We're trying to verify that the systems that we have that can attach to it along with what we're calling the octopus with several different attach points is viable. So the active duty guys are coming in here, they're making sure that as per Navy standards, this is going to work, it's nice and safe.
And all going well so far?
It's all going great so far.
All right. Well, thanks so much for talking with us. Again, this is Tim Goddard, the NBL flight lead here at the Neutral Buoyancy Laboratory. That's the NBL. And we'll go back now to Kyle in Mission Control. Thanks so much.